Welcome back to the video series on the solutions to the mock question in preparation for 2024 Waec exam. In this question, we are told a bicycle wheel of radius 21 cm is rolled over a distance of 33 meters. How many revolutions does it make? Well, for any circular object or circular wheel, one revolution is equivalent to the circumference of a circle. So, one revolution is equals to 2 pi r. Now, in this question, r is 21 centimeter. That means 2 pi r, or simply the circumference is 2 multiplied by 22 over 7 times 21 centimeters, which is 132 centimeter. So, if one revolution made by this particular wheel is 132 centimeter, then how many revolutions will be equal to the distance, which is 33 meters? Now, look carefully. The distance given to you is provided in meters. So you have to convert your distance, values into the same unit. So if 1 meter is equal to 100 centimeters, what will 33 meters be equal to? It is simply 33 multiplied by 100, which is 33,300 centimeters. So rather than writing 33 meters here, we are going to write 3,300 centimeters. 3,300 centimeters. So we can easily calculate the number of revolutions. So the number of revolutions will simply be just like you cross multiplying. Just like you are cross multiplying here. So it's going to be 3,300 centimeter times 1 rev over 132 centimeter. Centimeter will cancel centimeter. So 3,300 divided by 132 is going to give us 25. That means the answer is 25 revolutions. In this question, we have a trigonometry problem here. Sin x plus 20 degrees equals to cos x minus 10 degrees. Well, in questions like this, you have to be familiar with the angle formulas that we have. That is, sin x is equivalent to cos 90 minus x. You have to know this before you come into the exam hall. So if sin x is equals to cos 90 minus x, that means in this particular question, working with the left hand side only for now, this left hand side, if sin x equals to cos 90 minus x, so what will sin x plus 20 be? It is definitely going to be cos 90 minus x plus 20 now, not just x. X plus 20. So that's going to be cos 90 minus x minus 20. And that's cos 90 minus 20 is 70. That's 70 minus x. So just this left hand side, this sin x plus 20 is equivalent to this. So if that is equal, that means the last value here, cos 70 minus x, which I evaluated from the left hand side, I can now equate it to what I have on the right hand side here, cos x minus 10. So if their cosine are equal, that means the angles are also equal. That is, since the cosine of this angle is equal to the cosine of this angle, that means the angles itself now is equal. That means 70 minus x equals to x minus 10. So if you collect like terms, minus x equals to minus 10 minus 70. Minus 2x equals to minus 80. That means x is going to be minus 80 divided by minus 2, which is 40. That means x is 40 degrees. Option C. Question 29, we're asked to evaluate 11 multiplied by 7 in modulus 8. Well, there are different approaches to how to solve modulus question, but the simplest is that just ask yourself, 11 times 7 normally would give you 77, right? So the evaluation of 77 in modulus 8 is simply going to be the remainder when you divide 77 by 8. So what is 77 by 8? The whole number you will get is 9, because 8 times 9 is 72. So what's the remainder? The remainder is going to be remainder 5. The remainder is going to be 5. So it is this 5 that is your answer. Option A. In question 30, if 1 is added to the denominator of a fraction, the fraction becomes 1 over 2. When 3 is added to the denominator, both the numerator and the denominator of the fraction, it becomes 3 over 4. Find the fraction. Let x over y be the fraction. If 1 is added to the denominator of a fraction, since our denominator is now y, that means x over y plus 1. The fraction becomes 1 over 2. Okay, that's the first part of the statement. Well, we can just cross multiply. That means 2x equals to 1 into y plus 1. And that's simply 2x equals to y plus 1. Then the second part of the question, when 3 is added to both the numerator and the denominator, that means x over y. We are now adding 3 to both the denominator and the numerator. The fraction becomes 3 over 4. Well, we are also going to cross multiply here. That means 4 into x plus 3 equals 3 into y plus 3. That's 4x plus 12 equals to 3y plus 9. You can simplify for that. 4x minus 3y equals to 9 minus 12. That means 4x minus 3y equals to negative 3. So, if we call this equation 1, and this is equation 2, from equation 1, I can make y the subject of the formula. That is, from 2x equals to y plus 1, I can make y the subject of the formula, and that's going to be 2x minus 1 equals to y. So I can substitute 2x minus 1 into equation 2 wherever I have y. That is 4x minus 3 multiplied by 2x minus 1 equals to negative 3. That would mean that 4x minus 6x plus 3 equals to minus 3. And that would mean that 4x minus 6x equals to minus 3, because plus 3 coming to the other side will become minus 3. So that means minus 2x equals to minus 6. That means x equals to minus 6 divided by minus 2, which is 3. So if x is 3, what will be y? Y is 2x minus 1. That's 2 times 3 minus 1. That's 6 minus 1. And that's 5. So the fraction x over y is what? 3 over 5. Option C. Well, you can confirm your answer. If we say that the fraction is 3 over 5, right? So let's add 1 to the denominator, which is 5. So 5 plus 1 is 6. That means we have 3 over 6. And 3 over 6 when simplified is equals to 1 over 2, which is what we are given in the question. And to also confirm with the second part of the statement, if we add, this is the original fraction now, if you add 3 to both the numerator and the denominator, that is 3 plus 3 and 5 plus 3, that will give us 5 plus 3 rather, that will give us 6 over 8, right? So 2 here 3, 2 here 4, 3 over 4, which is also given in the question. So we have simply confirmed our answer. And if this is a theory question, that's how you can actually just see if your workings are correct. Question 31. In drawing a cumulative frequency curve, which of the following is usually plotted against the cumulative frequency? Well, the simple answer is the upper class boundary. If you've solved as many questions as possible under statistics, you will get used to what will be on the x-axis and on the y-axis whenever you are plotting your ogive, even quadratic equations, and so on. So, but for a cumulative frequency curve, it is you plotting the cumulative frequency against the upper class boundary.